Anybody out? Andrew, can you hear me?
Yeah.
Thank you. Thank you. There's something that happens sometimes where I can't be heard. Okay, I got people in here. Got 11 people in here. How you doing, ladies and gentlemen? Bethany, wipe the sleep out of your eyes. Adrienne, can I see you? Can I speak to you after class?
I'll be there.
Okay, thank you. Okay, I got 14 people in. I got more than that in. Guys are getting, you guys are to be commended for getting up this early. God knows I didn't want to. Are we doing okay? Did we get the last experiment done?
Yes.
You had, Larry, what did you have due this week? Was it the empirical
We
formula?
had the pre-lab for
Pre-lab for antacid, and you had to do the
yes.
empirical formula. Okay, I just needed to know what I'm up against. Let's see. Never mind. Empirical formula. Okay, I have the online. That's done. Okay. Okay. I'm trying to remember what else I had to. Oh yeah, that's what I have. Online, HCC, vape, and I have the two labs to prepare for. Okay. All right, guys. This lab is going to be fairly easy. There's just one little trick that we have to deal with, okay? Do you remember I said last week that it's easier to see a color appear than for a color to disappear? Do you remember I said that last week?
Yes.
If you don't remember, remember it now. That's what's happening. So because of that fact, we have to go from an acidic condition to a basic condition. In other words, we have to add base to our acid in order to see it, because phenolphthalein is purple in base, it is clear in acid. So what we're doing in this laboratory is we're intentionally we're adding too much acid to our antacid. Because we're adding too much acid to our antacid, the acid neutralizes all of the antacid, and the antacid chews up some of the acid. But there's some acid left over, and it's the leftover acid that we use to titrate with the NaOH. Now, that would be fairly straightforward, except there's one other little twist. When we are doing this particular reaction, there are 2 acids that are needed for every 1 antacid. So we got to account for that as well. So that's the general gist of what we're doing. It's the same basic principle that we did last week. Okay, are we seeing the slideshow now?
Yes.
Thank you. Okay, when it's pink, it's neutral. And when it's neutral, H plus equals the OH minus. Now, last week, we had 2 sources of acid that equaled the base. This week, we're going to have 2 sources of base that are going to equal the moles of the acid. I should look at this and do this. All right, now, we're dealing with 2 different reactions. The first is the neutralization of the acid by the NaOH. This is a 1-to-1 ratio. When we are using the antacid, we are using, in this case, calcium carbonate. That's reacting with 2 HCl's. So I need 2 HCl's for every 1 calcium carbonate. As a sideline, guys, a couple of years ago, I was in Williamsburg, Virginia. And because I'm kind of interested in things chemistry, I went into the pharmacy place. Do you know what they used as antacids back in colonial times? Anybody have a guess? They crushed up seashells. They harvested the shells that came off the sea. They knew that they were composed of calcium carbonate. So antacids in colonial times were literally crushed up seashells. Anyway, I thought it was fascinating. Maybe it's too early in the morning for such trivial facts.
No, that is pretty interesting. That is really cool.
Guys, what we're doing, first thing we're going to do is we are going to weigh the antacid tablet. We're going to literally take that antacid tablet, put it in a mortar and pestle, crush it up, make it into a fine powder. Then we're going to weigh it and we're going to put it in a flask. So we have the weight of our antacid tablet. Ultimately, what we're trying to do is we're trying to determine the percentage of calcium carbonate in that antacid tablet. Okay, now we're going to take that antacid tablet and we're going to put it under a burette with acid in it. It's initially marked at 0.70. I'm going to add HCl until the burette reads 20.70. And I'm going to also note the concentration of my HCl as being 0.1057. Okay, I'm going to look over. I'm going to look over at my base. I've swirled my acid around. I've added 1 drop of phenolphthalein. So all of my antacid is dissolved now. I'm going to then take it over to my base. I'm going to note the original volume of my base to be 5.75 milliliters, and I'm going to titrate it. I'm going to keep on adding base until it just turns pink. When it just turns pink, I'm going to stop it off, and I'm going to note the final volume to be 16.80 milliliters. I also need to note the concentration of the base. We good so far, guys? That is the experiment. For all intents and purposes, that is the experiment. We now got to go into the calculations. All right. Now, write this number down. What he wants you to do is he wants you to use your own average. Okay? It's been my experience in the past that some students do not do the first part of this experiment correctly, and they get the wrong concentration for your base. So I want you to start fresh now. I want you to write down that the base concentration is 0.1010 molar. That is what you're going to use as your concentration of your base for this week's experiment, not Tuesday's experiment. All right. Now, as I said before, we have 2 sources of base. We have the moles of the NaOH and we have the moles of the CaCO3. If I add those up, they're going to equal the moles of my HCl. So to get the moles of my HCl, same thing I did last week. I'm going to take my initial volume, subtract it from my final volume. That will give me my volume of my acid. I'm going to multiply that by 1 liter over 1,000. This is going to give me 0.02 liters times my acid concentration. This gives me a total moles of HCl of 0.002114. Base, I'm going to do the same thing, only its volume was 16.80 minus 5.75. I take the 11.05 milliliters of NaOH, multiply it by 1/1,000 milliliters, multiply that by the concentration, I get 0.001116 moles of NaOH. Have I said anything crazy yet? Are we good? Let me see. I want to see the expressions on your faces. I want to make sure that everybody's understanding what is going on. Garrus, no yawning. We good? Everybody good with this? Okay. So now, Marlene, what do you think I'm going to do?
You would find the moles,
Of what?
NaCl, or HCl, I mean.
We've already got that. We took the volume of my HCl and multiplied it by my concentration. I have my moles of HCl. I have my moles of NaOH.
So CaCO3,
How am I going to get that?
by finding the moles of, or getting the moles of HCl and NaOH and subtracting them.
Absolutely. That's exactly what I'm going to do now. So I've got I do that subtraction. I take my moles, total moles of HCl, and you have to understand that that's equal to my moles neutralized by NaOH and my moles neutralized by CaCO3. So when I subtract them, the number I get are the moles of HCl neutralized by calcium carbonate. Now the second trick. I have to realize there's a 2-to-1 ratio between HCl and calcium carbonate. So I have to take my moles of HCl and multiply that by 1 mole of calcium carbonate over 2 moles of HCl. This will give me the moles of my calcium carbonate. I then multiply those moles by my molecular weight for calcium carbonate, which is 100.09. This gives me 0.0499 grams of calcium carbonate. If I want the mass percent, all I got to do is take my amount that I determined to be calcium carbonate, divide that by the amount that the tablet was. That gives me a weight percent. Okay, that should be it. Okay. The extra slides that I have on here have to do with back titration that I went over last on Tuesday. It is part of the PowerPoint. It tells you how to account for the extra HCl that's added. Does anybody have any questions about what we're doing here tonight? Fairly solid, guys? Monica, give me a thumbs up. Okay. At this point, I'm going to end the show and I'm going to go back to the I got to find me. Oh, there it is. Stop share. There we go. Okay. As I always do, I'm going to go through the results and the Postlab with you. Don't worry, you get a free 5 points here. Put in any number. Oh, by the way, I'm instituting a new thing. It is called, well, actually, I don't have to because I take roll here. Ooh, that was bad. Let me do that before we continue on. All right. Marvina, I saw. Bethany, I saw. Gaith. Did not see you, Gaith. Natalie, I think I saw. Did I, Natalie?
Yes, I'm here.
Aaliyah, I saw. Corey. Abhishek, I saw. Andrew, I saw. Alexis, I did see. Kyle, you there?
I'm here.
Here.
No, Alexis, I did say that. Kyle, good. Marlene, I saw. Christine,
Here.
thank you. Taylor,
Here.
Monica, I saw. Adrienne, I saw. Elaine, I saw. Jeremiah, I saw. Maria, I saw. Jonathan. Garris, I saw. T,
I'm here.
thank you. Larry, I saw. And Paige, is Paige here? Okay, thank you, ladies and gentlemen. All right. Volume of HCl. You're going to look at the initial and final volumes of the data that's given you. Volume of the NaOH, same thing. So all you're doing is doing a subtraction of the final volume minus the initial volume. Moles of HCl, you're given the HCl concentration. Take the moles, take the liters in the first question, multiplied by the concentration you're given. That will give you the answer for moles. Moles of NaOH. You're going to multiply the milliliters in the first question by 1 liter over 1,000. Multiply that by 0.1010 molarity. That is the molarity I'm giving you for the standardization of your NaOH. Okay. How many moles of the HCl were neutralized by the tablet? For question A here, this is where you're going to subtract the moles of the NaOH from the moles of the HCl. That will give you moles of HCl neutralized by the tablet. How many moles of the CaCO3 did the tablet contain? You got to multiply it by 1 mole of CaCO3 over 2 moles of HCl. Grams of the CaCO3, you multiply it by the molecular weight. Last question. Okay. First A is going to be your original weight of your tablet. Percent mass, you use the answer from question 4 divided by the total mass of the powder to get question B. Okay. I want to know what you came up with. You don't have to show me the work for your trial 2, but you do have to give me the answer for trial 2. And then give me the average. And that should be the end of the questions. Any questions on the results? Okay, exit preview. Postlab. Preview. Start quiz. Okay. A student performs this experiment but forgets to remove an air bubble from the NaOH burette. During the course of the titration, the air bubble disappeared. Would the measured volume of the NaOH be incorrectly high, incorrectly low, or would the volume remain unchanged? You got to figure how that bubble affected the volume of NaOH. Second question, the bubble did not disappear. What would happen? Okay. This one, what happens in the normal experiment, what you're supposed to do is you're supposed to heat the antacid to get the entire antacid dissolved. If you didn't do that, sometimes what will happen is you get another precipitate forming. Instead of the stuff being calcium carbonate, if you're adding sodium hydroxide, what do you think the solid might be? You got to figure that out. You got to figure out what the solid could possibly be, and then realize what's happening to this particular reaction. Last question is going to be, you're given a data, basically you're given all the data you need to solve the problem, just like you did in the results section. Any question about the Postlab? Okay. And last thing, and then I can let you go, guys. That wasn't too bad. It's only half an hour today. Again, to get the data that you need, go to course content, go all the way down. Student data for labs. Open the sheet. Go down till you get the antacid. This is the information you have. They give you the molarity of the HCl. Do not, he gives this to you. What do you feel more comfortable with, guys? The 0.1010 or this number? He's changed this since last semester. Before, he didn't give this to you. He basically let you use your data from the first lab. What do you feel more comfortable with? This number for your NaOH solution or the one I gave you?
I like this number better, but I don't know what
Somebody
anybody
has
else is
chosen a
thinking.
preference. I'm sorry I confused you with the other number. Somebody
Yeah,
has
I
chosen.
agree. I like
Okay.
this number.
That's fine. That's fine. I don't care. I just want consistent results is what I want. So forget the 0.1010 as the molarity of the NaOH solution. Forget that number. This is the molarity that you will use. Fair enough, guys?
Yes.
Perfect.
Okay, that's all I got.
Have a good one, Professor.
Have a good day, guys. If anybody has any questions, I'm here right now.
Could you post the PowerPoint for this experiment? Because I don't think it's posted.
It should be.
Yeah, I don't see it either. That's what I was gonna ask.
Have the other PowerPoints been posted?
Yes.
Okay, I'm sorry if it's not posted. I will. You're right. I don't see it. I will post it.
Okay, thank you.
As a matter of fact, I'll do that right now.
Good. Thank you, Professor. Have a good day.
You have a good day too. Anything else anybody else has to say?
Professor,
Yes, sir.
so for these past two, error analysis, I noticed in the manual they don't pop up, so I just wanted to make sure.
Well, error analysis should be fairly easy for this one. Weren't you doing an error analysis with the Postlab?
Yes.
If you want to use that over again, go ahead. But you have to understand that you have to do the analysis portion of it.
Professor,
Yep.
I forgot to bring this up, but a while ago when we were talking, you gave me your phone number and you wanted me to remind the class or for you to give it to them because it's not on the syllabus.
What is it?
The phone number.
Oh. Would have been Garrus, it would have been helpful for you to tell me about that earlier when more
Yeah,
people
I'm
were in
sorry, I
here.
just remembered.
No problem. Guys, if you want to write it down, my phone number is 727-202-7275. People from my lecture should have the number already. My landline is 727-202-7275. If for some reason you can't reach me there, you might, emphasis on the might, be able to reach me through my cell phone, which is 707-843-1305. 707-843-1305. Somebody remind me about this again on Tuesday, and I'll repeat it again then. Paige, get here earlier if you can.
I have a question actually.
Okay, I'm here.
So I have you for lecture tonight as well, the 5:30 to 8 p.m. class. We have an
Yes.
in-class test today. I
Yes.
was curious, is it open notes or just
No. You
knowledge?
get. I told you you're allowed 1 page, 8.5 by 11, front and back, handwritten notes.
Okay, yeah, I asked you an email, but you didn't like go over it as much. You just kind of said yes, but I asked 2 questions, so I was kind of confused on what you were answering to.
You see, that's why that's the way I work, Paige. The more confusion I put out there, the more I can defend myself later.
Okay, well, thank you.
No, seriously, you're allowed 1 page, 8.5 by 11, front and back.
Okay, thank you.
Okay, if there's nothing else, Garrus, Jeremiah, I'm not going to say anything more. I need to speak to Adrienne for a second in private.
One more thing. Do you want us to measure that paper to make sure it's exactly 8 by 9?
Yeah, I'm going to be out there with the ruler, Jeremiah.
Okay.
I have better things to do with my life than measure out the pages of your notes. If you go a fraction over, Jeremiah, I'm going to pull your paper.
We'll make sure it's exactly 0.000001 off.
Yeah, and make sure you do the significant figures on that as well.
Yep. All right, have a good one.
You have a good one, Jeremiah. See you later.